So welcome back to the channel, guys. In today's episode, we want to evaluate this integral function. So without further delay, let's start the solution. So we'll be solving this integral function using the substitution method. This is because the function does not appear like something we can integrate directly. So we need to use the substitution method to help us reduce the function to something that we can directly integrate. So in this case, we're going to let our x cubed plus 2 equals u. And then we're going to differentiate this function. Differentiate, I said, not integrate. We're going to differentiate this function, and in differentiation, we're going to multiply the power by the expression and subtract 1 from the power. So we have 3x squared dx. But what we need is our dx, so we need to divide both sides by the 3x squared to give us dx. So our dx is going to be equals to du over 3x squared. Now what we need to do next is to substitute this dx into the dx in the integral function. And also we are going to substitute our u into the integral function. So we have a new integral function, which is going to be x squared into bracket u cubed. Our dx is now du over 3x squared. Now in this new integral function, you can see that we have x squared there, so those two can divide through, and we are left with u cubed du over 3. Now from here we can see that we can factor out 1 over 3, which is a constant. So our 1 over 3 into the integral of u cubed du. So we reduced that function, the first integral function, to this function. So we can easily integrate this function. And integration, what we do is we add 1 to the power, and whatever we get, we divide the whole expression by that number. So we add 1 to 3, it's going to become 4, and we are going to divide that expression by 4 as well. And we're going to add a constant function, which is c. Remember, we still have our limits 1 and 0. So now that we've integrated this function, what we need to do next is to go back to what our u is and substitute our u back into this expression. Our u then is x cubed plus 2. Now we have it raised to power 4, not 3 anymore. Our limit 1 and 0 still remains. Now we want to substitute the limit because we've already integrated this expression, and this is what our answer looks like. So now we need to solve out the limits that we have there. In solving the limits, you're going to uh, subtract. You're going to substitute 1, the upper limit first. You're going to substitute the upper limit into the expression, and you're going to subtract the lower limit from the expression. So you're going to substitute the 0 and subtract it from the expression where you added when you substitute the upper limit. So now we have x to be 1, and also x to be 0. So 1 raised to power 3 is 1 plus 2. You're going to have 3 raised to power 4. 3 raised to power 4 all over 4 minus 1 over 3 multiplied by 0 raised to power 3 will give you 0 plus 2 will give you 2, then raised to power 4 all over 4. Then we can see that in this equation we can have our 3 raised to power 4 is 81. So 81 over 4 minus 1 over 3 multiplied by 2 raised to power 4 is 16 over 4. Now we can factor out 1 over 3 because it's common to both sides of the equation. Now we have 1 over 3 into bracket 81 over 4 minus 16 over 4. And this will give us 81 minus 16 will give us 65 over 4. So multiply this, just open the bracket. That will give you 65 times 1 over 3 times 4, and that is 65 over 12, which is our final answer for this integral function. So this is the solution to that integral expression. I hope you understand the process, and I hope you've learned something from this solution. If you do, please ensure to subscribe to the channel, give this video a thumbs up, and please share to your friends and colleagues who need to understand how to solve an integral expression. And that is the end of the video. Thank you for watching, and I'll see you in the next video.